So we are starting with AS level math paper 1, and math paper 1 is known as P1. 9709 is the syllabus code for AS and A2. And then for P1 there are three variants, that is 11, 12 and 13. The variant in our region is 12. In some other regions the variants are 11 and 13. Now we are starting with this topic which is called coordinate geometry, and even before that let me give you a brief overview of what P1 is all about. So there is P1, and in the first year we do S1. Exceptions are there. Some people they prefer to do M1, but usually the trend is P1 and S1. So now let me focus on P1. There are 8 topics of P1. So let me just label them. And this is more or less the order in which we'll be completing these 8 topics. So the first topic that we will do is coordinate geometry. And we won't do the whole thing. We would do half of the thing. That is coordinate geometry, and we are focusing on the straight line aspect of it. That is why this half of the chapter will be done again at the end, and that's CG again, coordinate geometry, and we would focus on equation of circle. Pretty interesting topic. Now in O-level math, you have studied circle, you have studied circle property and angle property and tangent properties, things like that. But over here, you will actually study equation of the circle. So topic 1, that would be the ending of P1. So we would start with coordinate geometry, and we will go through all the other topics. And at the end, we will end with coordinate geometry. Now, what are the other topics? The next one, that is circular measure. And circular measure and trigonometry, they are attached together. So it's our choice. We can either do trigonometry first and then circular measure, or vice versa. So these two, the order could change. The fourth topic, we can do quadratics. And then we can have AP, GP, binomial. This chapter collectively is known as series. So series has 3 components, that is AP, that is GP, that is binomial. And then we have the topic that is differentiation. So we have differentiation, and we have integration. This is the symbol for integration. And last but not the least, that is functions. So that is the order in which we will study coordinate geometry, circular measure, trig, quadratics, and then all this thing. And somewhere in between, we will be S1 and then again P1 and so on. So let me just decrease this brightness a bit, and that looks good. So now we are starting with P1. And the first topic that we will start with, that is coordinate geometry. And now, from now on, instead of using the whole big name, I'll just refer to it as CG, coordinate geometry. Now, if we talk about coordinate geometry, let me draw y-axis, let me draw x-axis. Now, what is coordinate geometry all about? Coordinate geometry is about points and more. So we start with points. We can create different shapes, a triangle, a rhombus, a square, a parallelogram, rectangle, and so on. And then based upon that, we can be talking about many more things. Now this thing over here, that's the origin. Let me label a point over here. Let me call this point as Q, and the coordinates of Q are XY. That means I have walked from the origin x units to the right, and I have walked up y units. So that's what the coordinate means. Basically, it gives us a sense of direction with respect to x-axis, with respect to y-axis. X-axis is the horizontal axis and y-axis is the vertical axis. Now, you all have naturally done O-level math. If I talk about the vector OQ, that can be written as xy. If I talk about magnitude of this vector, that is x square plus y square square root. Isn't the magnitude of vector the same thing as distance of O of Q from O? Distance of this point from the origin. So distance of Q from origin can be done using Pythagoras theorem. So let me just draw the x-axis like this. Let me draw the y coordinate like this. And let me join these two. So let me join it properly. So if this is x, this is y, this is right angle, this is d, therefore d square is x square plus y square. Therefore d is square root x square plus y square. You take square of each, add it up, and then take the square root. That is d. That is basically Pythagoras theorem. Now we move to the distance formula. So if I talk about the distance formula, again I've drawn the x-axis, the y-axis, and let me just draw 2 points like this. So this is point A, the coordinates are x1, y1. This is point B, the coordinates are x2, y2. And let me just change the color of this one. So let me change it into purple. Okay. And let me use horizontal, red color for the horizontal and blue color for the vertical. And let me also change the color of this one to green. So totally, no, not black, purple or green. Okay. So now if we are talking about the distance between 2 points, so I'll label everything. Distance between 2 points A and B, can I say that this is the same thing as length of line segment AB? Yes, I can say that. Line segment is part of a line. A line is infinitely long, but line segment is between 2 points. So I can find this thing. Now, if I label it, this is y1, this is y2, this is x1, this is x2. I've drawn a horizontal, I have drawn a vertical like this. Now the base is in red color, the height is in blue color, the hypotenuse is in purple color. And naturally, I would again be using the concept of Pythagoras theorem. Now, if we focus on the base, this is x1, this is x2, therefore the base is the bigger value minus the smaller value. If I talk about the height, y2 is the bigger value, y1 is the smaller value, so the height is y2 minus y1. And when I ask for acknowledgement, I want you to acknowledge it in the WhatsApp group. I think your WhatsApp group has that admin thing in it, so you can reply to me individually and make sure you mention your name. So therefore, if I talk about hypotenuse, so hypotenuse square is equals to the base square plus the height square. Let me write the base first. This is x2 minus x1 whole square. Let me write the height first, which is y2 minus y1 whole square. Let me put a black thing over here, a plus sign, and this is equals to hypotenuse. So therefore, simply hypotenuse should be x2 minus x1 whole square, y2 minus y1 whole square, the whole thing under root, and that is how we have created the distance formula. So we all know the distance formula. I have shown you the creation of the distance formula. When you have this conviction that a certain formula, you know the basics, of course within the limits of the syllabus, so you won't be forgetting it. So now let's go ahead and use this distance formula. So again, usage of distance formula. So if I use the distance formula, let me write a point A, which is 0, 1. Let me write a point B, which is 5, 11. I need to find the distance AB, magnitude of the line segment, distance between 2 points. So it's a good idea that I write it underneath it so that I can have a feel of what is the direction in which I'm doing the subtraction. So I'm doing it from top to bottom, top to bottom. So this is X, this is X, this is Y, this is Y. So therefore, first of all, let me write down the template. That is the square root like this. And then there are 2 brackets with the square in it. So what goes in the first bracket? 0 minus 5 whole square. What goes in the second bracket? That is 1 minus 11 whole square. So 0 minus 5 whole square is basically the base square. 1 minus 11, the whole thing square, that is the height square. And now let me simplify this thing. This is 5 square, which is 25. 1 minus 11 is 10. 10 square, which is 100. Square root remains. And this is square root of 125. I can further simplify it. I can write this thing as 25 into 5. According to rule of indices, AB raised to power of m, that is A power m, B power m. So that is root 25 into root 5. Root 25 is 5, root 5 remains as it is. So that is the magnitude of the line segment AB. Pretty basic stuff. Let's proceed with this. Let's now talk about the concept of midpoint of a line segment. Let's use the word average, so it's very easy to remember it. It is the average of the x coordinates. It is the average of the y coordinates. And let me change the color. So color and purple. Okay. Now over here, I think let me just double check my charging. It's all good. So now over here, if we talk about a point A, which is x1 and y1, I talk about a point B, which is x2 and y2. And I think again a good idea to write underneath it. So let me focus on the x coordinate, that is in red color. Let me focus on the y coordinate, that is in blue color. So therefore M is the midpoint of line segment AB. Understand the terminology. M, we take the average of x1 and x2. So x1 plus x2 divided by 2. And we take the average of the y coordinate, y1 plus y2 divided by 2. And that's how you get the answer. Pretty basic. So let me do a worked example. A simple, basic worked example. Let me write A, 0, 1. Let me write B 5 11. I'm just using the same coordinate that we so frequently used. This is 0, this is 5. So this is 0 plus 5 divided by 2. This is 1, this is 11. This is 1 plus 11 divided by 2. Put a comma over here, put a bracket over here, write M. Therefore, the coordinates of M is 5 over 2, comma 12 over 2, which is 6. Again, pretty basic stuff. Now, let me draw some lines. So, let me draw a red line like this. Let me draw a blue line like this. Let me draw a green line like this. Let me draw a purplish line like this. Now I've drawn 4 lines, and let me just realistically write some coordinates. So first of all, I'm talking about, let me choose a different color. I'm talking about slope, inclination. I'm not using the coordinate geometry terminology as yet. So I'm talking about slope and inclination. This is a positive slope. Why? Because you move right, you climb up. You move right, you climb up. So this is the feeling of climbing up. Got that feeling? The blue line, that is negative slope. Why? You move right, you go down. You move right, you go down, and so on. So it has got a feel of climbing down. The green line, it's a horizontal surface. So it's a horizontal line. There is no change in height. And this is a vertical line. There is no change in what you call base. So I'm using the term base, that is the horizontal, and no change in height, that's for the vertical. A horizontal line has no change in vertical, a vertical line has no change in the base. Now, if I take the same thing and let me just copy these 4 lines and let me paste it over here and let's work it out. So now in the first line, let me label this as A 0, 1. Let me label this as B 5, 11. And now I am introducing the concept of slope, inclination, rise over run, and gradient. That is the official name. So gradient is defined as change in y over change in x. y2 minus y1, x2 minus x1. Let me just shift it a bit down. So that is the first thing, and let me just shift it. Okay. So this thing is change in y. This red one, actually blue one, because we use the blue color for the height, that is change in y. And this red one, that is change in x. y2 minus y1 over x2 minus x1. So now over here, if I calculate the gradient of AB, that is 11 minus 1 over 5 minus 0. This is 11, this is 1, that is this thing, and this is 5, this is 0, that is this thing. So therefore, this is 10 over 5, which comes out to be 2. This is a positive slope. The calculation says it all. Pretty basic. Let me move my picture from this side to this side. Okay, that makes more sense. Now, let's look at the second example. Let me write C over here. Let me write D over here. Let me write C as -1, 5, and let me move 4 units right. So this is 3, and let me go down 4 units. So therefore 1. I'm just doing the calculation myself. So now gradient of CD, again let me focus, change in Y, which is 5 minus 1. Change in X, that is -1 minus 3. So 5 minus 1, that is 4. Minus 1 minus 3, that is -4. This comes out to be -1. Yes, it has got a negative slope. Now let's focus on this. And let me just push this thing to the corner. Okay, I don't know, some issue with this. Now let's move up. Now when I look at this line, let me label the point K and L. It's a flat line. Now if it's a flat line, I'm not comfortable with this thing over here. Now if this is a flat line, the coordinates of K 2, 4, coordinates of L 6, 4. Now look at the Y coordinate. The Y coordinate is unchanged. So now when I calculate the gradient of KL, that is 4 minus 4 over 2 minus 6. That is 0 over -4. It could be any 4. 2 minus 6 or 6 minus 2 doesn't make a difference. This comes out to be 0. And I'll focus a bit more on this. I'm right now using a calculator. 0 divided by -4, it comes out to be 0. On the other hand, if I talk about Q and R, this is 1, 7. This is 1, 2. What do you observe over here? We observe that the X coordinate is unchanged. So therefore, gradient of QR, that is 7 minus 7, that is the change in Y. And let me also change the color over here. This color should be blue. And over here, this color over here should be red. So blue is for height, red is for base. Blue is for height, and this time red is 7 minus 2. This is 7 and 2. Let me just do the correction. I think I got mixed up with the numbers. So this is 7 minus 2. That's the change in Y. There is change in height, but 1 minus 1 in the denominator. So now let me just draw a black line over here. This is 5 over 0, and this is undefined. When you use a calculator, the calculator will say it's a math error. Now let's focus on this. Why does the calculator says this? So now over here, let me just pick this thing up all the way over here, and let's focus on this. So let's go to the next page, and let's focus on this, and let me shift this thing all the way down. Now over here, when we say that the y coordinate is unchanged, what is happening? Let me make you understand this thing. And over here, the x coordinate is unchanged. Okay, so let's get started with this. Let's say, why can I say 0 divided by any number is 0? I'm making a claim. And let me draw a box over here. Now, first of all, if I say 0 divided by 4, let's say this equals to a constant small a. That means 0 is 4 times a. Is there any number which I can multiply with 4 and I'll get a 0? I'll say yes, that number is 0. Therefore, a is 0. There is a number such that if it multiplies with 4, it will make it 0. So which number is that? So that number is 0. That makes sense. 0 divided by any number is 0. But on the other hand, if I talk about something else, and if I say any number divided by 0 is undefined. So let me write undefined. And over here, what do I write? Let me just change the color. So let me first draw a blue color like this. And then I'll draw a big red color like this. Okay. So any number divided by 0 is undefined. That is over here. Let me write, let 5 divided by 0 equals to small k. 5 is k times 0. Is there any number such that if we multiply 0 by that number, will it give me 5? That's not possible. Such a thing is not possible at all. Any number cannot be divided into 0 parts. Then there is no concept of division. So therefore we say it's undefined. And for our purposes, we can also say infinity. In reality, it's a bit different. But for right now, we can say it's undefined, it's infinity. So I hope this concept is all good, all clear to you. So now just pause for a second and acknowledge on the WhatsApp that this is all good, all clear. Till that, I'll just pause the recording for a while. So now we have understood the concept of gradient. Now let's talk about equation of a line. Now, equation of a line, there are two formats. The first format, y is equals to mx plus c, which you have done in ordinary level maths or IGCSE. This format has a slope, has a y-intercept. So m stands for slope, c stands for y-intercept, and therefore we have this thing. This is called the slope intercept format, form or format. On the other hand, we have this thing that is y minus y1 is equal to mx minus x1. M, still the slope, and x1, y1, that is a coordinate. That is a point, the coordinates of a point. So let me just erase coordinate. I think point is perfect. So therefore, this is known as slope point format or form. So there are two options that we worked with. The first one is y is equals to mx plus c. The second one is this. There is no limitation by the examiner. Both formats are perfectly fine to use with. It depends on what your convenience is. So now if I start with this idea, and if I say that let's use the new format, which is y minus y1 is equals to mx minus x1. Let me just illustrate it with a single example. Find equation of a line passing through the point (3, 4) and having a slope of 2. So first of all, the slope value is 2 and the point is 3, 4. So therefore, when I do the solution, x1, y1, instead of x1, y1, I have 3 and 4. And instead of the slope, I have this value, which is 2. Actually, let me write this value as 2 over 5. So this is 2 and this is 5. Now it says, if I do the working, so y minus y1 is equals to mx minus x1. Y minus 4 is equals to 2/5 x minus 3. Just stop over here. Yes, what you got over here, yes, this is the equation of line. It's perfectly done. It's all good. It's all clear. Now, if you want to expand it, that's another thing. Maybe the examiner will say, write the equation in the form, let me write it, ax plus by plus d equals to 0, where a, b and d are constants to be found. So yes, the examiner has a habit of asking in this format. So what will we do now? We will have to expand it. 5 times y minus 4 is 2 times x minus 3. So let me just erase this green color for right now. Let me choose this color, which is blue, and I'm multiplying it like this. I'm choosing this red and multiplying like this. So instead of opening up with a fraction, I play it safe. I work with integers. So now what happens? 5y minus 20, 2x minus 6. Transfer all the terms to the left hand side. 5y minus 2x minus 20 plus 6 equals to 0. 5y minus 2x minus 14 equals to 0. Is it of this format? Almost. You should write the x thing first. Negative 2x plus 5y minus 14 equals to 0. This is perfectly good. Or you can write this thing as plus 2x minus 5y plus 14 equals to 0. This is also perfectly good. I have simply multiplied by a negative sign and changed everything. So a, b and d are constants. That constants would vary. Over here, if I write ax plus by plus d equals to 0, let me shift this thing a bit down. So over here, if they want the constants separately, I'll write a is negative 2, b is positive 5, c is negative 14. And over here, if I write it like this, I'll write ax plus by plus d equals to 0. Therefore, a is negative positive 2, B is negative 5, D is positive 14, like this. So this is also good, this is also good. So I hope this is all good, all clear. Now, I think I'll just pause till here so that there are some people who joined for the first class. There are some who will be joining it later, so they can have a pretty good idea about it. So let me stop lecture number 1 at this stage. And in the next class, we'll be talking about parallel lines, perpendicular lines, isosceles triangles, and a lot of new stuff. Till the next class, take care.